Okay, this is a worked example in the forces section. This is really a fairly straightforward example illustrating the fact that if net forces on a particle are not don't net out to zero, then you will get some acceleration. This one is two particles A and B. Let's have a look. Two particles A and B are connected by a light inextensible string. Particle A has mass of 5 kilograms. Particle B, a mass of 15 kilograms, B hanging directly below A, and a force of 300 newtons applied vertically upwards on particle A, causing the particles to accelerate. Okay, so first things first, let's get our diagram here. There's the two particles, 5 kilograms and 15 kilograms. We've got this interconnecting light inextensible string. Of course, we've got the weight of the particles due to their mass under acceleration due to gravity. So 5g and 15g. In this example, I'm taking g as 10 meters per second. Okay, so we've got those forces, and then the 300 newtons being applied vertically upwards on particle A. Right, so there's our diagram. I think it's pretty clear how all the forces are nicely marked on. So we've got a fairly good representation of what's happening. Now, this is another example of systems of particles. In truth, most of the questions that relate to acceleration in the forces section tend to be systems of particles, usually a couple connected together, and that's exactly what we've got here. And the characteristic of these, of course, is that when they accelerate, because they are connected, then they will accelerate at the same rate of acceleration. So the first thing we're doing is we're pretending really this whole thing is one particle. A and B together are one particle, and as such, we're not actually interested in interconnecting pieces. I mean, the forces net out to zero anyway, because it's light and inextensible as this string. We've got two forces here, which is going to net out to zero. So we're not actually interested in those in this bit of analysis. But what we are interested in is a total mass of 20, an upward force of 300 newtons, and a downward force of 5g newtons together with this of 15g newtons. So if we consider the whole system and these particles being as one, then if we apply the equation we have for Newton's second law of motion, then we just put our values in. So the other thing we're saying here is as far as motion is concerned, upward is positive. So we're looking at the net force upwards. So that's 300, which is this 300, minus the combination of these 5g and 15g downwards here. And that's going to be equal to the mass. And obviously the mass of the system is 5 plus 15 times its acceleration. Okay, so if we substitute g equals 10 in there and rearrange, this is going to give us an acceleration of 5 meters per second. So this is accelerating, and we set it upwards, so it's accelerating upwards at 5 meters per second. This is quite typical of these questions, because the second part is the tension in the string. Now, for this, what we want to isolate out one of these particles. In this case, probably easier to do B, and in general, it's usually if there's a chain of particles connected, then it's usually the last one in the chain, which is usually the easiest one to deal with. So we're just going to consider this 15 kilogram particle here and the forces on it. Well, we've got this tension force here, and we've got the weight of 15g here, and these are what are acting on the particle, which has that has a mass of 15 there. So again, here's our Newton's second law of motion equation, F equals ma. And again, thinking upwards, the net force upward is going to be the tension, T minus 15g, and that's going to be equal to the mass of 15 times the acceleration, which we have calculated from part 1 or part A of the question. So substituting g equals 10 in there, this is going to give us t equals 75 plus 150 or 225 newtons. So that's the answer to part B. A relatively straightforward problem. Most of these are straightforward once you've drawn a clear diagram. Hopefully that has been helpful, and I'll see you next time.